Hello my dear students, this is Physics Balaji. Today let us discuss a problem based on hydrostatic pressure in fluid mechanics. Here in this question it was given, a slit is cut at the bottom along the right bottom edge of a rectangular tank. So you can see it was the rectangular tank and it is the right bottom edge. Here we have a hole. This slit is closed by a wooden wedge of mass m. It was the wooden wedge having mass small m and apex angle theta. The vertical plane surface of the wedge is in contact with the right vertical wall. This vertical surface of wedge is contact with right vertical wall and it is the hole of the container. Coefficient of static friction is given. To what maximum height water can be filled in the tank without leakage from the slit? To what maximum extent we can fill the water so that water will not leak out like this. Width of the tank is given B, that means inside breadth will be there like this for this tank. So this breadth was given B and density of the water is given rho. Now look at carefully. Gravitational force of the wedge always acts downwards and water will produce a buoyancy force on the wedge so the wedge can move upwards. As we increase the level of water, buoyancy force increases, then it will try to move upwards. This motion is opposed by the friction between wedge and the vertical wall, that will be downwards. Horizontal force given by the water on the wedge will be Fh and the wall will give normal reaction like this. Now at equilibrium, upward force will balance with downward force and left side force balance with right side force. Now let us balance upward force equal downward force. Here upward force are buoyancy upwards and mg and friction downwards. Here it is ready to slip as we fill water to maximum height, so then it will be Fs max condition. Buoyancy force formula will be rho g volume inside mg plus mu s n. Here volume inside means this volume we have to take. This volume formula area into breadth inside. So rho g volume inside formula area of this part. Area of this part is half into base. This base height we have to find. From this right angle triangle this is h. Then this can be found as tan theta equal to formula opposite side by adjacent side h. This opposite side we can find as h tan theta. So area formula half into base h tan theta here and height was h and breadth will be there, inside b will be there. So this breadth is this one. So total we got volume inside, volume of the wedge inside the water, weight mg downwards mu s into n. That derivation you can see once again here. Along horizontal, so this wall will give normal force on the wedge and this water will give horizontal force on the wedge. At equilibrium, so these two should get balanced. To find horizontal force, average hydrostatic pressure into normal area. Here hydrostatic pressure at the top is 0. There is no pressure due to water. Here pressure due to water will be rho g h because at depth h. Then average of these two value will be 0 plus rho g h by 2 into normal area. It was the normal area. This normal area we can find by using height h, breadth b. Now this n value substitute in equation 1. Here rho g h square b tan theta by 2. This one equal mg plus mu s. N value, substitute this value here. So g common and cancel. From this you can find h value. It is the maximum extent we can fill the water so that wedge will be ready to slip and water will ready to leak. Thank you.